All right, guys, so our next lesson, we have the sixth circular function. So suppose theta is an angle plotted in standard position, and P, point on xy, is the point on the terminal side of theta, which lies on the unit circle. So that point xy is on that unit circle. The circular functions are defined as follows. Of course, sine of theta is y. Cosine of theta is x, and we did that last time a lot with our right triangle trig and filling out that unit circle. Then we have tangent of theta. Well, tangent of theta is sine over cosine, and if sine is y, cosine is x, that's where you got tangent of theta being y over x, provided that x is not 0. Then we have our cosecant, which is the reciprocal of sine. So we have 1 over y in this case, but y cannot be 0. Secant is the reciprocal of cosine, so it's 1 over x, knowing that x is not 0. And then cotangent, of course, is the reciprocal of tangent, so we're going to flip that around to x over y, provided that y is not equal to 0. So really, though, what we need to think about this is we have tangent of theta can be changed into sine of theta over cosine of theta. Cotangent can be cosine of theta over sine of theta. Secant can be 1 over cosine, and cosecant can be 1 over sine. These are some trig identities that you really want to make sure that you memorize so we can manipulate and find out these values without a calculator. So you want to keep in mind that we're talking about the circular function, and then we got to think about the positive, negative, and what quadrant it is, depending on what the question is asking. So right now we're finding out what secant of 60 is. So the first thing I want you to think about is when we think of that unit circle, is secant on the unit circle? Technically, no, but we can manipulate it to something that is on the unit circle, right? So secant is 1 over cosine of the degree, which in this case is 60. We then know that at 60, our x value is 1/2. So I get 1 over 1/2, which dividing by a fraction, same thing as multiplying by the reciprocal. So we get the value of 2. For B, cosecant, well, again, not on the unit circle. So let's talk about something that is on easily defined. So that's 1 over sine. 1 over sine of 7 pi over 4. Well, think of your reference angle, right? 7 pi over 4, the reference is pi over 4, which is the square root of 2 over 2, right? But you also keep in mind that 7 pi over 4 is in the fourth quadrant. No, sorry. Yeah, fourth quadrant. So it's going to be negative. And now let's actually calculate that out. Now, some of you, I'm going to simplify this the long way. Some of you might be able to recognize when it's going to be ahead of time, but I'm going to do every step. So of course, dividing by a fraction is multiplying by the reciprocal. So we have 2 over the square root of 2. But most mathematicians and most math classes want you to rationalize the denominator, which means we're multiplying the numerator and denominator, in this case, by square root of 2. This then leads us to negative 2 over the square root of 2. All over. Well, the square root of 2 times the square root of 2 is 2. And what do you know? We can reduce that. So our answer is negative square root 2. Cotangent, of course, is 1 over tangent. And 3 is actually not easily found on the unit circle. So what we're going to do is actually use our calculator. Now, of course, my calculators are graphing and it's more extent. Remember, you can't use these, but you will have your sine, cosine, and tangent on there. So, of course, cotangent is 1 divided by. Now, one thing you want to keep in mind also is that if it does not show degrees, it automatically means radians. So I actually have to switch this because I was doing degrees with my secondary 3 class. And I get approximately negative 7.015. Usually they go out to the 3rd decimal place, so that way it gets you ready for calculus, which makes you always go out to the 3rd decimal place. All right, let me go to the next page. All right, so here we're going to find tangent, where theta is an angle coterminal with 3 pi over 2. All right, so let's think about this. At 3 pi over 2, which is down here, right, our cosine of theta is our x value, which is 0, and our sine is our y value, which is negative 1. We know that tangent of theta equals sine theta over cosine theta, which means we're going to have negative 1 over 0, and we state this as undefined value because we cannot divide by 0. Okay, so now in E here, we're finding cosine of theta, where cosecant theta equals negative square root of 5, and theta is in the 4th quadrant, okay? So let's manipulate this to something we can use, which is 1 over sine of theta. So 1 over sine of theta equals negative square root 5. Now, usually when we manipulate things and stuff, we want our trig functions to be in the numerator, so I can flip them, right? So this tells me that sine theta equals negative 1 over the square root of 5. Okay, now what? Because we have to find cosine theta. So what does sine and cosine theta have in common? Well, what they have in common there is the Pythagorean identity. Remember, and that tells us that cosine squared of theta plus sine squared of theta equals 1. And now we're going to solve. And don't forget, we're in the 4th quadrant. This helps us because our answer could be negative or positive, so it tells us which one. So if we keep going with this, we end up getting that cosine squared theta equals, let's see, that would be 5 there. 5 over 6. Let's see, sorry guys, I'm doing some math in my head. Oh, because that's positive, so we're going to subtract, right? So it's going to be 4 over 5. Now we got to take the square root, right? So we get cosine theta equals the square root of 4 is 2. The square root of 5 is still the square root of 5. But again, we want to rationalize this. And at this point, it's positive, negative until we figure out what quadrant. So when I rationalize it, I get that cosine theta equals 2 square root of 5 over 5. And since we're in the 4th quadrant, cosine is positive. All right, now we are going to find sine theta, where tangent is 3. And look, what quadrant is this? From pi to 3 pi over 2 is quadrant 3. All right, so let's make this work for us. Tangent is sine theta over cosine theta, and that equals 3. Now, we cannot assume that sine is 3 and cosine is 1. That might be the simplest form. So we can't just assume that. So what we're going to do is manipulate this around. So I can multiply cosine to both sides and get sine theta equals 3 cosine theta. Okay, and we're going to solve for cosine because we want everything in sine. Okay, and this will make more sense in a minute. So I'm going to divide by 3, so 1/3 sine theta equals cosine theta. Now, yeah, I said I want everything in sine, right? Well, that's because we're going to use the Pythagorean identity again. But instead of cosine squared, we're going to put the 1/3. Actually, I'm going to move it up here so I have some room. 1/3 sine theta squared plus sine squared theta equals 1. Again, let me convince you. The Pythagorean identity is cosine squared plus sine squared equals 1. Cosine is 1/3 sine theta. So let's multiply this out. So I get 1/9 sine squared theta, because I squared it, plus sine squared theta equals 1. I'm going to put it together. This is 1/9. I have to put this in as a fraction, right? So this would be 9/9, because it's 9/9. So actually I have 10/9 sine squared theta equals 1. Okay, multiply both sides by 9/10. So I get sine squared theta equals 9/10. Take the square root and get sine equals plus or minus the square root of 9 is 3. The square root of 10 is the square root of 10. Now I'm going to rationalize this and pick which quadrant is put, or positive, negative, by what quadrant it is. So sine theta equals, we get 3 square root of 10 over 10. And sine in the third quadrant is negative. So there is our answer. Okay, knowing these things, now we actually can fill out the rest of the chart. Remember the chart that we had all the degrees, the radians, and then we had sine, cosine, and tangent on our unit circle. Knowing how to flip things around, now we would be able to expand that chart into secant, cosecant, and cotangent if you would like. All right. So now we're going to move on to finding angles that satisfy circular function equations. So our next example asks us to solve some very basic trigonometric equations. So we're going to find all the angles that satisfy the given equation. Now, all the angles doesn't mean we're just going around once. We want to solve it in a way that we can get everything as many times as we want. And remember, that's from the other lesson where we did our 2 pi k, depending on the revolution, right? So let's see what we can do from here. I'm going to get another color just so I can draw these out. And I'm sorry for my circles that are definitely not circles. So I've got my unit circle. Now, in what places would we have the x value being 1/2? Well, the x value being 1/2 is at pi over 3. The other place we have pi, or x equal 1/2 is down here, where, let me not make that look so much like half. There we go. And this, of course, is negative pi over 3. Now, if we talked about where this is going clockwise, what would it be? it would be 5 pi over 3, because of course, think of it, 2 pi would be 6 pi over 3, and we're subtracting because we're going clockwise, pi over 3. So that gives us 5 pi over 3. Okay, so we have two spots on the unit circle in which we can get cosine theta equals 1/2. But that's only if we go once around. So we need to talk about what if there's a bunch of rotations. So just like we started before, to get all the values that we end up in quadrant 1, we would get pi over 3 plus 2 pi k. Where for the quadrant 4, we would look at 5 pi over 3 plus 2 pi k. So again, where you're going to make your mistake is when you forget that we're not just talking about the first rotation. There is no indication that it says, hey, we're only going from 0 to 2 pi. We are doing any angle in any given situation. So we need to make sure that we're including all rotations. All right, let's go on to the next one. Not bad circle on this. Okay. Sine is 1/2. Well, sine is y. So it's got to be down below. Sorry, guys. And remember, let's talk about the values off of the reference angle. So on the reference angle, when sine theta is 1/2, that is pi over 6. But we're down here. So this would be negative pi over 6. And this one, well, we're going clockwise, so this would be pi over 6 added onto it, right? So let's talk about these values. 2 pi would be 12 pi over 6, and we're going clockwise one. So that's actually 11 pi over 6. And then here, this would be pi, which is 6 over 6, but we're adding 1 onto it, so it's 7 pi over 6. All right, again, these really aren't looking at a connection between the two quadrants, just like above here. So we're going to make two different equations. So we looked at, we're going to land in quadrant 3, and the way to do that is to take 7 pi over 6. But of course, because we're doing all rotations, we're going to say plus 2 pi k. And then it lands in quadrant 4, so that looks like we're going 11 pi over 6. All rotations is 2 pi k. All right, cosine of 0. Well, 0 is the y-axis, right? So right here. Okay, and of course here is pi over 2, and this one is 3 pi over 2. So here's our other thing. We can make our two equations, right? We could say pi over 2 plus 2 pi k for every rotation that hits this spot. And we would then have to say 3 pi over 2 plus 2 pi k, which hits every terminal in this spot, so terminal. But if you look at this connection, right, this is actually 180, 180, 180. So we can combine these two and say pi over 2. And instead of adding a full circle, we're only actually going to add half a circle, because that gets to our 3 pi over 2. So we could say pi over 2 plus pi, because that's the 180, right? K for our different rotations. Either one's fine, putting the 2 or 1, but this is nice to see that connection. All right, we're going to do the same thing again, but this time we're going to use our other trig function. Now, the way to do that is, of course, to bring it to something we know. So secant is the same as 1 over cosine, which equals 2. But again, on our unit circle, we don't look at 1 over cosine, we look at cosine. So what we're going to do is flip it or multiply each side by cosine and then divide by 2. So we get cosine 1/2. Well, didn't we just do this on the other side? Oh, no, we didn't. We did sine 1/2, right? So let's make our unit circle. Where is cosine of 1/2? Or did we do this on the other side? Yeah, didn't we do this on the other side? We did. So it's the same value as the other side. So I'm not even going to draw it out, guys. So it's the same as our A value because I manipulated cosecant theta of 2. And we ended up with pi over 3 plus 2 pi k and 5 pi over 3 plus 2 pi k. Getting all those rotations in. Okay, tangent. What were we doing at the beginning of this lesson? We were changing tangent into sine over cosine. So let's do that now. So sine theta all over cosine theta. Now, this is a square root of 3. But what I want you to keep in mind, guys, is square root of 3 on our unit circle? Kind of, right? Because what is its relationship with? Well, square root of 3 is almost like square root of 3 over 2. So what could I do there? Well, that would mean sine is square root of 3 over 2, and cosine would have to be 1/2. So see how the 2's would cancel, right? And then we're left with square root of 3 over 1. So we got to find out on our unit circle, where is sine, square root of 3 over 2, and where is cosine 1/2? Okay, well, if we think about it, that's the first quadrant, right? And that is pi over 3. So that's awesome. But that's positive square root of 3, right? What's another way that we can make a positive number? Negative over negative. So the other thing I have to look for is negative 3 over 2 for sine and negative 1/2. So it has to both be negative, which is right over here. And this right here is a reference of pi over 3, which we have to think, if we have pi, which is 3 pi over 3, plus another pi over 3, we have 4 pi over 3. But I want you guys to think about this as like what we did in C on the other page. This is that pi, that half a circle. So we don't need 2 equations to hit every coterminal rotation. We just need 1. We could say pi over 3, I don't know why I'm using the black pen right now, plus, and again, we're going every pi, okay. All right, let's do cotangent. So cotangent is flipping that, right? So we get cosine of theta all over sine of theta, which equals, actually, this one's not going to go anywhere, right? I can't get to negative 1 here. I mean, some of you might be able to see it, right? Because how would you get the value of 1? Let's continue with what my train of thought was right here. How do you get the value of 1? Anything over itself, right? 5 over 5, 10 over 10, so on and so forth. So where in the unit circle can we have sine and cosine be the same value? Well, that's at our 45s, right? Our pi's over 4, so we get the square root of 2 over 2 all over the square root of 2 over 2. Now, we have a negative, though. Does it matter which one's negative? No, as long as they're both not negative. So our first part on our unit circle that we will find where cosine is negative square root of 2 over 2, and sine is positive square root over 2 is right over here, right? And of course, if this is pi over 4, and we're subtracting it from pi, we get 3 pi over 4. And then we have to remember there's one more place, because I can do positive square root of 2 over 2 divided by negative square root of 2 over 2, and that still gives me 1. So where is cosine positive and sine is negative? Right over here. And again, that's negative there, so 7 pi over 4. But this is like our half a circle, so we only need to make one equation for this of 3 pi over 4 plus pi k. Awesome. And now we get every rotation, and we are done with this lesson.